Hello, my name is Ajit Shah and I will demonstrate you how to run non-compartmental analysis on pharmacokinetic modeling program PKMP. First thing, you need to log into the system, and once you log in, then on the dashboard you need to select the file for analysis, and you can use browse functionality to determine the location of the file. And once you find your file that you would like to utilize for analysis, select the file and then you can upload the file. Once the file is uploaded, you will get the message file has been successfully uploaded. Then go into the NCA PK module. If the file is for the oral or extravascular analysis, select that option. The list of your files that will appear on the screen. Then select the file that you wish to perform the analysis. The file is displayed at the bottom and all the file headers, they appear in the first column. The next step is to map the file headers with the program predefined headers as shown here. So for example, subject needed for the program is associated with the subject in the file header. Time in the program is associated with the time in the file. Concentrations are CP nanograms per ml, and the group variable is if the file has a treatment as a header, then select that as a primary group, and then the secondary groups can be your period, sequence, dose, etc. Once you do this mapping, then click on the next button, and then it will take you into the analysis screen where you have the options to create the graphs, descriptive analysis, and NCA oral analysis. First, we would like to see the graphs. So let's click on the graphs, and as you can see that the X and Y variable for the time and concentration are already selected, as well as the treatment is selected for the grouping purposes, and then we will create the graphs for the treatments that we have in the data set. And so now the concentration versus time plots for your reference and the test treatment have been created. Then you can go back one more time, and then you can create descriptive analysis of the data set. Again, the treatment has been selected as a grouping variable, and then next you want to select concentration so that the descriptive analysis for the time and treatment will be performed. And as here the data is shown for the time, treatment, and descriptive statistics being displayed here. You can download this data or create the graphs. You can select the mean, and the graph for the both treatments, mean data versus time is plotted, and this chart can be edited for the titles and other display options under the edit chart functionality. The next thing, you want to perform the non-compartmental analysis. Go back twice, and then click on the non-compartmental analysis screen. Here the program is requiring to identify what is the treatment field in the data set. So treatment is treatment. If there is no treatment, then you select the no treatment. This is useful for identifying the dose and association of the subject with treatment that is needed for the program. And as you can see that the program has picked up the treatment and subject and their associated doses based on the database. The unit of the dose is milligrams, unit of time is hours, concentration is in the units of microgram per ml, and we have the three options to perform the AUC calculation using linear trapezoidal rule, log linear trapezoidal rule, mixed log function, and in this case we are going to select linear trapezoidal rule, and then we are going to submit. And all the NCA analysis is being performed. And if we click on the subject 1, here is the calculation of the terminal phase elimination rate constant. The program has the default for the selection of the last 4 points of the log concentration versus time data. And then you can change that selection by clicking on other selections. That now we can select the 6-hour data point and 24-hour data point, and then it updates the calculation of the slope and KEL. And if you are satisfied with that selection, then you can save, and the default gets changed to the blue color, meaning that user has made the changes in the selection. Rest of the green selection indicates that the default has been accepted. Once you are satisfied with the calculation of the KEL, there are options. If there are some abnormal data points, that you can remove and perform the operations. It also allows you to compute the partial AUCs. For example, if you want to compute AUC from 0 to 3 hours, then you can create the AUC for 0 to 3 hours. You can generate the same thing for all subjects, and then it gets posted in the data set. Once you are happy with your selection, you can perform the additional AUCs calculations if needed. Calculated data tab shows that the calculations for the time, concentration, AUC calculations, and all associated PK parameters. Once you are happy with your computations, you can perform the additional analysis as shown in these tabs depending on the data set. This data set is appropriate for the BE analysis, so we will select the BE analysis for a 2x2 crossover study design. On this screen, you need to do the mapping of your group variables with the program needed variables. For example, treatment is treatment, period is period, sequence is sequence, and once that mapping is done, you can click on the next treatment, and then the list of the parameters including the partial AUCs that you computed are displayed here. And for the BE analysis, select the parameters Cmax, AUC, AUC infinity for the BE analysis, and the intermediate analysis for the AUC and the Cmax is shown here, and then your reference treatment is R. Then click on perform BE analysis, and here the BE analysis is being performed for you with 95%, 90% confidence interval for the ratio of the test to reference is 106.3 and upper ratio 138.1, and same thing for the Cmax. The confidence interval for the 90% ratio is shown here, and the same thing for the AUC infinity, it is shown. It also produces the ratio analysis for the AUC and the Cmax as well as AUC infinity for each subject, and then also displays the descriptive analysis which can be downloaded uh, to your uh, documents. And this is all needed for the non-compartmental analysis. Similarly, you can perform the non-compartmental analysis for the IV bolus and IV infusion data sets, and perform additional analysis such as dose proportionality, ANOVA, as well as the sample size calculations for the BE in this non-compartmental module. Thank you.